Hello students, in this video we'll show how to prove the law of sines. Let's consider a triangle A, B, C. What I'm going to do is I'm going to put our triangle in its circumcircle. So our triangle lies in this circle over here. Here's our triangle. That's our triangle A, B, and C. And then what we can do in this triangle is I can take from any vertex and I can draw a diameter of this circle through a vertex. So what I'm going to do is I'm going to draw a diameter of this circle. So let's say that the center of the circle is right over here, approximately. Then I'm going to draw a diameter of the circle. So there's our center right there. That's our center. I'll call it center O for center of our circle. And then what I'll do is I'm going to connect that center to the point, connect this, and we're going to form a right triangle by connecting the vertex B to this point over here, E, that we constructed. So let's draw that line from B over to E. And then that becomes a right angle, because this from A to E is a diameter. So if I look at B, that is going to encompass half the circle. So that is going to be a right angle. And now, what do we have over here? We can see now, looking at this triangle, that the arc that goes from B, E to A, this arc right here, the measure of that arc, well, that's going to sweep out the arc from B to A. Now notice that from A to C to B also sweeps out the same arc. So this angle over here, the angle at C, let's call that the angle gamma, the angle in the triangle that corresponds to C, has exactly the same measure as this angle over here because they sweep out the same arc on the circle. So this angle over here, AEB, is also equal to gamma. So I have two angles of gamma, but now we have a right triangle. The right triangle ABE is a right triangle. And so what can I say? I can say that the side length C over here, which corresponds to the opposite side, so the length AB is equal to C. So the length of AB is equal to C. And the angle ACB, this angle, is equal to gamma. And by these sweeping out the same arcs, that's the same angle that is the same thing as angle of AEB. So AEB is also equal to gamma. And this triangle is a right triangle. So, putting this together, what can I say about the sine of gamma? So the sine of gamma, the hypotenuse is this pink line over here, which is the diameter of the circle. So let's let R be the radius of the circumcircle. That's called the circumradius. So that's called the circumradius. Then, by trigonometry, we know that the ratio of opposite over hypotenuse is going to be the sine of the angle. So the sine of gamma is the opposite, C, over the hypotenuse, which is going to be twice the radius or the diameter. So the conclusion from this is equal to that the sine of gamma over C is equal to 1 over 2R. Now, this is an invariant condition. This could have been done for the vertex A or the vertex B or the vertex C. So each of these ratios, sine of gamma over C, sine of beta over B, sine of alpha over A, are all equal to 1 over 2R. And so by rotation invariance, the labels of the vertices, we have the law of sines. The law of sines says that the sine of alpha over A, the length of the side BC, is equal to the sine of beta over the length of side. So the sine, so beta is over here. That's our beta, and this is our alpha, and the side length that corresponds to b is AC, so that's going to be AB, is equal to the sine of gamma over c is 1 over twice the circumradius. So in this extended law of sines, we not only conclude that the ratio of the sine of the angle to the opposite side lengths are all equal, but each of these quantities is equal to 1 over twice the circumradius of the circumcircle. Thank you very much.